Okay. Let me show you in the space now. And can you see that? This is our open space. This is our open space, and we have a venter machine just sell the electronic components. And this is our this is my game PlayStation, some kind of with the LV, Lexi one, and this is our screen, and over there is our I want to build a CNC wood CNC Mosul CNC, something like that, and the laser piano, something like that. Oh, we have a PC, very early time PC over there. Can you see that? Yes, this is our how can I see that? This is our open space, and often we talking and chatting here, and we have a workshop in the back. Cannot go because I'm using the cable. But I will show later. Maybe it depends on the workshop. So yeah, and yes, we are back to normal now. Uh, but in the January, we are asked to stay at home and wear the mask and keep the distance. Now everything is just fine, except you have to measure the temperature when you go into the entrance. So yeah, everything is just fine for us. But I'm more worried about the COVID-19 in the future. I mean, some locations, some area, they are poor and they will haven't has any kind of medical things. So we find that the ventilator is a machine that can help people can breathe when they have the COVID-19. When they very bad, so cannot breathe. With the ventilator, they can survive for a long time because the virus will be killed by himself, not any kind of medicine now. So ventilator is a kind of a survivor. Then I researched in the markets. I found that the professional ventilator is very expensive, and a lot of people cannot afford. So, and we found that the ventilator for the emergency healthcare is cheap. I will show you the link that is from the I will send the link. It's from Taobao and just some kind of Ali, Amazon, something like that. It's very cheap. The price is almost less than $10. No, $30, something like that. It's very cheap, but it's very hard to use because you have to push again and by hand. And but the people need a ventilator all day long, so people cannot do that all day long. And yeah, so we have a research find a lot of people build a open ventilator, very general, and they provide all the details and all the things goes to make the ventilator is more cheaper. And but their how can I say, their technology are a little bit harder, or the price still very high. So we think our make space can make something more cheaper. So something like Africa, India, some kind of place can using that technology, or using the ventilator to at least help the patient suffer the time. So we make this kind of ventilator. And here is our how can I say that? It's our workshop. I will show the video to tell us how to build a ventilator. If you have any question, just let me know, and then I will pause and give some explanation. And yeah, feel free to stop me. Yeah. Okay. So here we go.
Disclaimer: this ventilator, while we believe is helpful, has not been clinically tested or approved by any medical administrations. If there are professional ventilators available, please use those. We are not responsible for any injuries or deaths caused by this piece of equipment.
I'm Tao. I'm from Mushroom Cloud Makespace.
Can you hear me? Okay. So what I have seen, you don't listen it. I just explaining how to. Okay. Okay. Yes. I just explaining the putter. The putter is most important thing in this ventilator. And if you cannot find the putter, maybe it's difficult to build this ventilator. This putter, we patch it by less than $20. It's a very important activity. Um, yes, this kind of push things. The vertical motor. I mean, yeah. That kind of how can I say ASV things is just for the sleep apnea, and the air pressure and the quantity is different. Is different, but the basic serial is the same, and that will be using some uh, air pump to do that. But the air pump is not powerful, power enough. Basically, a human, adult human, need about almost. Let me remember. Um, a normal will be 500 500 micro liquid. Oh,
I just
thank
wanted
you,
to
Lisa.
say that the one that I put in there is probably not the right one. I don't know if it's the one that you need, but it was just an example I found.
Yeah, thank you, Lisa. That's a very good link to explain what is putter, because I just using that word from Google Translator, because I have no idea what they call in English. Sorry about that. Yeah, maybe liner accurator will be more accurate for that. Okay, thank you, Quentin. Yeah, in Chinese we call it 推杆, 直线电机, something like that. Yeah, now Tao is installing the lining actor actor character. Sorry. Liner actor. Okay, thank you. No, I will change to liner actor, because more easy to understanding. So yeah, thank you, Quentin. Thank you for understand. Yeah, now Tao is installing some kind of a board. This board is laser cut by laser cutter, and this kind of egg is for the airbag in the left right. The airbag will be put on the space that with a curve. So will be fixed on that. Okay, Nanopiece, thank you for how can I say that pronunciation? Yeah, thank you.
Linear actuator.
Linear actuator. Okay. Sorry. Linear actuator. Okay. Thank you. Thank you. I think I will put the whole video in Wiki, and we can modify it, make it more better. And it's also welcome you to help to make it better, because I think that kind of things need to community. How can I say community concentrate? No. whatever need to be
Collaboration.
Sorry, contribute. Yeah. We just do a little things, and I think this kind of things need us to contribute ourselves ability, because nobody will be will do anything. Yeah, corporate also. Yeah. Now the Tao is building a role for the push things, because we need to push the compress the airbag. So we have tried a lot of how can I say, the structure to compress the airbag. Single way to press the airbag is failed, because the airbag will be move the position when the force is too much. And we try two sides compress with the 3D printer gear, and also fail because the force is too much, and the 3D printer gear is not big enough. So we now this kind of structure is can be very easy to compress the airbag with the force, and the structure now is okay. And Tao is our staff of Mushroom Cloud Makespace. He's in charge of the tech support. He's very familiar with the laser cutter, and his hand draft is very good. Yes, you can see that the liner actuator is push the liner. Can I say that? And the liner will be connected with the rod, so they will be have a same compress to the airbag. Quentin, you asked problem with speed. The liner speeder is I think it's a little bit slow, but think about the breath time. Adult will be 16 to 20 around per minutes, almost about 4 seconds for one breath. It's okay. It's okay. Yeah, in this part is a little bit harder and difficult to install, but this is most harder part. Yes, Roxy, you're right. And the now Taos in installing that part now is using the wood board to build. But in future we can try to build it with another material. What we think is just using that wood board and aluminum profile, because it's cheap and easy to find. And if we have a we can using laser cut or any kind of a tools to make it. Otherwise, another material may be difficult to find and to product. How much is the pressure? Basically, the pressure compressed by the airbag will be over 200 Pascal, and my research is about 300 or 400 Pascal. It's enough to compress the air. Okay, let me stop a little bit. And the ventilator is installed, and now we are showing how it works. And this is Kevin, who is how can I say it? 12 years old. Yeah, 12 years old. And I asked him to write the program, and he will introduce about the function, and will teach us how to install the program and explain the program.
Thank you, Tao, for installing our ventilator for us. My name is Kevin Zheng, and I will be explaining the operation of the ventilator, how to install the code into the ventilator, as well as explaining the code. So our ventilator has 3 modes. It starts off at manual mode. So manual mode works when you press a button, it'll cycle the ventilator once. Now you can change the amount the ventilator compresses with this potentiometer. And you can see the value here. For example, if I change it to the lowest, which is 600, it'll compress quite little and retract. Now if I change it back to the maximum value, it'll compress all the way and then retract all the way. Now to switch modes, simply press this button. Now it's in automatic mode. Automatic mode will will repeatedly compress and decompress. First of all, the value does not change. It works the same way as the manual mode. But the second value, delay, works by changing the amount of time between each cycle. For example, if I lengthen it by changing, now the delay is 2.5 seconds. So each time it decompresses, it'll wait 2.5 seconds until the next compression. Just like that. Now if we change it back to the shortest delay, after 1 cycle, it'll instead wait 0.3 seconds until the next compression. To change the mode, again, press this. However, you might need to press and hold for manual mode because it only works on a specific time. You have to press the button at a specific time, or else it will not change the mode. The next mode is dynamic mode. It is currently under development, and because we have not connected an airflow sensor onto it, it's going crazy right now. So we'll continue development of our airflow sensor, but also because of the high cost of the airflow sensor, we will not force you to use the airflow sensor. However, if you would like to, it definitely works. But some airflow sensors might not be compatible with our program. Next, I'll be explaining how to enter the code into the board and also explaining the code. To upload our code onto the ventilator, first of all, you have to go to Arduino.cc. Since my computer already has the Arduino IDE, I will not be showing this. However, once you get to the Arduino.cc, there will be a downloads menu, and then you can download the newest version of the Arduino IDE. After that, go to our GitHub page, which is over here, and then you press download code. So you download the zip, decompress the zip, and you'll see these 2 folders as well as this README. After that, you put the liquid crystal I2C into your documents, Arduino, libraries, into that folder. Since we've already done this, again, we'll not be doing this right now since it's already done. For the ventilator code, I would suggest you move it to a more secure location, such as documents, or inside, or even better, inside the Arduino folder. However, if you would not like to, that's also perfectly fine. After that, you want to launch the Arduino IDE. So, Arduino IDE. It'll take a while to launch. And then after that, these two are already open because I had opened them previously. But you first press File, Open, and then you navigate to whichever place you place the ventilator code folder, and then you open the document inside. I already have that open, so pretty simple. After that, you go to File, Examples, Wire, and I2C scanner. Again, I already have that open, so I do not need to open that. But this will help scan for the display and make sure you have the good address. For example, here the address is 0x20, but you might have a different address. I'll show how to scan for the address. First of all, you plug in your Arduino, then you go into Tools. Make sure the port is correct, the Arduino Uno. Then you go to the board and select Arduino Uno or the Arduino Leonardo if this one says Arduino Leonardo. And then after that, you upload the I2C scanner onto it. It's done uploading. You enter the serial monitor and you see which place it has found an address. So it's usually the first one, so again, I2C address device found at address 0x20, and that's correct. So after that, you can simply close this program and close this file. After that, to upload, you can upload our ventilator code, again, by pressing this button. It will compile a sketch, and then it will upload it. After that, you're completely done, and you can move on to the next video, which will show you how to operate the ventilator. As you can see, this is our code for our open source ventilator. First of all, this is basically just initializing all the variables, such as the pins, the different thresholds, the max and minimum extension, those types of stuff. Down here, we have the changeable variables, such as the mode, the delay, the extension, etc. And then down here, we have, and then moving on, we have the void setup. This is basically what runs first for one time. This basically just sets up everything. It first initializes the display, then it initializes all the outputs. Then we have two functions right here. Two functions. These two functions, one of them is the void show data. This one basically shows the important information, such as the mode, the extension, the time, etc. And then the next function is the push-in, which basically just cycles the ventilator once, and the input, you basically just have to put in what the extension is, and it'll just do one cycle. The use of these functions is because these functions are basically used a lot, and it would be quite complicated for us to basically put all of this code into every place where it's needed. So instead we created this function, and all we have to do to call this function is just write show data, or push in this case. And also it's quite easy to change or debug the code because we just have to change it here and we don't have to change it anywhere else. The final bit is the void loop. This is where everything happens. So, first of all, the airtime and delay between breaths. Airtime is basically the extension, because our extension is calculated in time, not distance, because we don't have a sensor for that. And basically, it just maps the potentiometers to the max and minimum values of these two things. And the delay between breaths is obviously the delay between two values for between two cycles for the timed mode. So now it's basically just three modes. Mode 0, manual mode. Basically, if you press the button, it will cycle once. If it's in timed mode, it'll basically cycle every few seconds, and this amount of time is determined by this delay between breaths, which can be adjusted with a potentiometer, and the mode. And the dynamic airflow mode basically uses the airflow sensor and senses when the patient is attempting to breathe. So it basically just takes in the reading from the airflow sensor here, and it calculates if it's above the certain threshold, which we have defined above. And if it is, it basically just cycles once. This calibrating area is basically is used to basically just set up our sensor, because our sensor is quite a crappy one, and basically you just have to wait, and it has to stabilize, because if we don't do that, it has a lot of noise, which is quite strange, because you would expect a bit of noise, like 1 or 2%, but our sensor just went from 0 to 100, just like it just kept oscillating, so we have to wait about 25 seconds, which is slightly unfortunate, but if you have a better sensor, you can completely delete this. And down here is basically just the mode switch. A few things of note is here the address. Our address is 0x20. You might have to change the address depending on your. You definitely have to change the address depending on your display. So just look up I2C address finder, and there'll be some code for it there. This code is all written in C++, and it will be uploaded to an Arduino and an Arduino Leonardo, and with that it can control the Arduino Leonardo has a built-in H-bridge, which is basically a motor control chip, and with that it can control all the motors that we need.
Okay. Now. The who process is okay, and yeah, I have to say that the who system is a little bit easy, so we call it easy ventilator. But the idea is that we can make it a very cheap one. So here is our how can I say that, a bomb bill of material. In this kind of bill, you will see that we just using the 1, 2, 3, 4, 5, 6, only 6 electronic parts, and in this kind of things, we make it how can I say that, working properly now, and we. My voice, can you see? Okay. So I just said that the whole process now is finished, and the ventilator the whole process is okay now. And what you have seen that this easy ventilator is very simple, and but the idea is to make a ventilator very easy to build and very cheap. So as you can see that the bill of material is very simple, and only 22 um, 22 material and components. The whole system building is using about 1 hours, and the structure will take about 40 minutes, with 20 minutes setup, and yeah. How many circuits? I have tested for one day, 24 hours, still works, and now it still works, and I will show how it works. And let's see. And here is our ventilator. Now, our okay. When I press the works. And this is auto. Can you hear that? Can you see that? Okay, let's. I will try to. Yes, the airbag will be replaced. I believe that's one person for one airbag. Yes, I have checked the other one's ventilator open source, and I have checked a lot, and their ventilator is using some very expensive material, something like gill or motors, very powerful and very expensive. And I find that this liner actuator is cheaper than the others. And I believe that will be more cheaper than theirs. And also, I'm very happy to how can I say that a lot of people do private things for us, and I have write my blog or my article here, and you can have see. Sorry, it's in Chinese, but with the picture you can see I have reference a lot of people's work. And you also can see the preview design. So any question? I'm not sure. I speak all the thing to you. Any question, Lisa? Do you think we can? Do we have some other questions?
So I'm wondering like how you like what kind of research did you do to figure out, for instance, exactly how much pressure you needed to put? Like, how did you go about figuring out what you actually needed to build in the first place?
We actually we have some air pressure sensors, but because it's expensive, so we not put in the bomb, but we have a test in our experimentation, and we just tested for that, and yeah, we have air pressure sensors. The air pressure sensor is very expensive. Am I clear to answer this question? I'm not sure. Maybe not.
So what I meant was, like, in the design process, when you were first figuring out how you were going to put the thing together, what were the steps you took in the early design process when you said, like, oh, how does the ventilator work? Exactly how much pressure do we need? Because I mean, I can imagine if you put too much pressure, you're gonna, like, hurt somebody's
Yeah.
lungs, and not enough pressure.
I will share another. How can I see that? I will share the article. I have a search from a lot of website, and this is this page will be yeah this kind of things is from Japan, and we found the article and the medical things in this how can I see that in this kind of yes in this part of things they provide the pressure uh, the pressure the quantity, so we can make sure not too much. The one centimeter H2O water cleaner, yeah, some kind of thing. Yeah, so that is the date we get. So we're just using that data to make sure not to harm the people.
That's really great. Somebody asks, did you run into any supply chain problems when you were sourcing your parts?
That's the great part because we're in China. So as I shared, we can touch the things only. This ventilator, this airbag is about 18 MB. It's almost let me see 12 $12. No, 15. No, yeah, $15, even less. Yeah, $14, $14. And this kind of this kind of a liner is only 135. So almost $7, $8, $18, something like that. And will be arrived in 2 days. So it's really faster for us. This is the price, and yeah, very fast. And yeah, the rest of them is very normal to find. Something like the element profile, something like that. It's easy to get. So the supply chain is not a problem for us, but I'm not sure. But I think the most of parts is easy to find because the aluminum profile easy to find, and then the wood part is easy to find and easy to be produced, to be cut, something like that.
Somebody asks, are there universal worldwide medical treatment standards or recommendations for air pressure values? And do they depend on body size?
Yes, the adult and the human, the children is different. So we give the option to switch the value and the pressure time. That's why we do that, and I found very. Let me find the. I found YouTube that's introducing one kind of a ventilator, and uh, I I I think this one this kind of ventilator things is just using air pressure, and also he can use that switch to change adult or children, and that's the idea. What our easy ventilator do? We can switch. We can change uh, the speeder and the quantity value. Yeah, because adult and the children is different. Adult is 16 to 20, and the borner children were 14 to 16 minutes. Okay. If you don't have any questions, and I think um, this workshop will be finished. And thanks for your join, and I hope you can make it by your own. And if you have any questions, just let me know. And my address, email address, I will write it down. And it's rockets.xia@df.com. And
Thanks
if you
so
come,
much. Sorry, go ahead.
if you want to go to Shanghai, and welcome to our Mushroom Cloud Makespace.
All right, thank you so much, Rockets. This was really great. I just want to remind everybody that if you want to grab the shared notes before you leave, click over to the shared notes, and in the top right-hand corner, there's these two arrows that sort of point across each other, and that's the import, export, and you can download those notes to your own computer, and then you'll have all the links to the GitHub, the video that we watched, the article that Rockets provided, and also, of course, the wiki page that has the full parts list and the software and other files you need to download. Thank you so much. This was a really great workshop.
Thank you.
So glad to have you. Thanks.
Thank you. Thank you. See you. See you soon.
Wait, are you still there, Rockets?
Yes.
The video mentioned that there was another video. Is there another video, or was that just because I noticed that video was longer?
Yeah. Basically, I asked Kevin to make another kind of video to mention some notes also some kind of tips, but his how can I say that his work, his study
His
work
schoolwork?
is too much, so unfinished. So yeah.
Gotcha. Okay. Well,
Yeah,
we'll keep an eye out for it when
yeah,
it's ready.
yeah. We will try to update. How can I say that? We will make it better. Yeah.
Fantastic. Thank you so much.
Thank you. Thank you. Wow. The add-on is really nice. I'm really enjoying about that. Thank you. Thank you for this event. Thank you.